Hello, this is Mr. Win, and this video is about fundamental trig identities. So there are many fundamental trig identities that you need to know and memorize. Here's a list of the ones you need. You should already know the first ones. The reciprocal identities. Sine of theta or x or u is equal to 1 over cosecant of theta x or u. If you solve this for cosecant, you get cosecant of u is equal to 1 over sine of u. Then cosine is equal to secant, or related to secant. Secant is related to cosine, tangent is related to cotangent, cotangent is related to tangent. Alright, then we have the quotient identities. So tangent is equal to sine over cosine, and then cotangent is equal to cosine over sine. We got TOA, O over A, and then A over O. The new ones that we don't have yet are the Pythagorean identities, there's 3 of them. But sine squared plus cosine squared equals 1, that's the main one. Then you have 1 plus tangent squared of whatever angle equals secant squared of whatever angle. Then 1 plus cotangent squared of whatever angle equals cosecant squared of whatever angle. Then we have our cofunction identities for component angles. So hopefully you notice that like sine of 60 degrees is equal to cosine of 30 degrees, right? So here's what they are, because there's the phase shift of each other. Then we have our even and odd identities. So you'll use this a lot when solving, but when you see cosine of a negative angle, you can replace it with a cosine of the positive angle. Same for secant. Secant is even, so secant of a negative angle is equal to secant of that positive angle. Then for odd, originally the original function is equal to the negative f of the negative angle, but they just divide both sides by negative 1 to get f of negative angle is equal to negative f of x. Alright, so if you see sine of negative u, you can change it equals negative sine of positive u, and so forth. Alright, in the notes, you can always rearrange an identity. So if you solve for the other function, you'll get also usable identity. So sine squared plus cosine squared is 1 can be rearranged into sine squared equals 1 minus cosine squared. Also, 1 plus tangent squared equals secant squared can be rearranged to tangent squared equals secant squared minus 1. And I'll show you how to use that in a little bit. So here's how you create the Pythagorean identities. So actually all you have is you draw a right triangle and just use Pythagorean theorem. Alright, so this is A, this is B, this is C. So A squared plus B squared, C squared. Cosine squared plus sine all squared equals 1 all squared. Now cosine of x all squared is going to be cos squared of x. Then sine of x all together squared is going to be sine squared of x, and then 1 squared is 1. Alright, so note cosine squared of x means cosine of x times another cosine x, and not cosine of x squared. So here, notice I did cosine 30 times cosine 30, I get 0.75. If I do cosine of 30 squared, I get negative 1. Again, cosine x times cosine x, that means cosine of 30, the value of that, times another cosine of 30, the value of that. This is cosine of 900 degrees in this case, and that's just a single angle, right? So we're not trying to do cosine 900, we're trying to find cosine 30, which is root 3 over 2, times another cosine 30, root 3 over 2. Alright, same for sine squared and tangent squared and all that. Alright, now you only need to memorize the first one, sine squared plus cosine squared equals 1. The other two come from dividing the entire equation by either sine squared x or cosine squared x. So here's the first one. I have the original equation in black, and I divide everything by cosine squared. Well, sine squared by cosine squared, that's opposite over adjacent. That is tangent, but it's squared, so it's going to be tangent squared. Cosine squared by cos squared is positive 1. Then 1 over cos squared, remember 1 over cos is secant, so 1 over cos squared is going to be secant squared. That's how you get the second one. Now, they did reverse 1 in tangent, but that's okay. You can rearrange it as long as it stays the correct sign. And here's the last one. I divide everything by sine squared. Sine squared divided by sine squared is 1. Cos divided sine is cotangent, but it's squared, so cotangent squared. And then 1 over sine is going to be cosecant, but it's going to be cosecant squared because this is sine squared. Alright, so only memorize the first one, then you can find the other two by just easy division. So, if secant of x is negative 3 over 2 and tangent of x is positive, find the values of all 6 trig functions. So we've done this before, so here's how we'll do it. Identify which quadrant we're in. So secant of x, which is related to cosine, is negative. That means we're in either quadrant 2 or quadrant 3 because we're on the left side of the y-axis. Alright, tangent is positive in quadrant 1 when x and y are both positive, and quadrant 3 when x and y are both negative because O over A. Negative y divided by negative x is going to give you positive. Alright, so the only thing they have in common is quadrant 3, so we must be in quadrant 3. Now they gave us secant of x is negative 3 over 2. We could use reciprocals to say cosine of x is negative 2 over 3. But here, we have two choices. We can draw the triangle, do Pythagorean theorem like before, or use the trig identities. And then keep in mind the positive and negative signs for quadrant 3. So here's the picture. Quadrant 3, we're left 2, and then my hypothesis is always positive. We need to find this. I did Pythagorean theorem right here. So 2 squared plus b squared is 3 squared, 4 plus b squared is 9. Subtract 4, b squared is 5. b goes plus or minus 5. Now we figure out what sign are we. Now we're going down. We're in quadrant 3. Why is it negative? So we have to use the negative square root 5. Right, when you square root numbers, always plus and minus. So now we know that sign. We could say, oh, that's O over H, so negative root 5 over 3. But I could also done the Pythagorean identity, right? Sine squared equals 1 minus cosine squared. Right, so I just did this one, but I solved for sine squared. I just moved this cosine squared over. Alright, so, oops. Alright, so we know cos squared is, or we know cosine is negative 2 over 3. So I replace this negative 2 over 3, square that. A negative squared is a positive, so this stays minus 1 times 4 over 9. Then we're going to combine like terms, common denominator, so 9 over 9 minus 4 over 9 gives you 5 over 9. Then get rid of the square power, you square both sides. Square root of 9 is 3, square root of 5 is 0 to 5, and it's plus or minus, but again you should know that this is negative because we're in quadrant 3. Once you know this, you can flip it to get cosecant. Make sure you rationalize the denominator, so it's negative 3 over root 5, 5 times top line root 5 over root 5 gets this. Then to do tangent, you could do O over A, so I could say negative root 5 over negative 2, makes a positive root 5 over 2, but I could also do sine over cosine, which was what I got earlier. You do fraction by fraction correctly, you still get this and then. And then if I want to go cotangent, I say 1 over tangent, which is 1 over that, which gives me this. Alright, we need to simplify trig expressions. So what can we do here? We could factor out the GCF of sine x. So I get sine x, then it'll be cosine squared x minus 1. Now cos squared x minus 1 we saw earlier. Oh, let's do this. So sine squared plus cosine squared is 1, right? So cosine squared minus 1 is going to be negative sine squared x. So I'm going to replace that inside with negative sine squared x. Now I'll multiply sine x times negative sine squared x will be negative sine cubed of x. Alright, factoring. Hopefully you've seen different squares. So sine squared x minus 1 is the same thing as like saying x squared minus 1 a squared minus 1. You'd square both things. Do a 1 plus minus, right? Or minus plus. The order doesn't matter. So what times what's sine x squared x? Would be sine x times sine x. What times what's 1 is 1 and 1. Negative opposite signs, right? 1 positive, 1 negative. You also have the x method, the AC method, or the guess and check method. Right, if I had to factor 4a squared plus a minus 3, you'd say, oh, 4a times a, 3 times 1, and fix the signs. Same thing here. So here, a stands for tangent of theta. Right, so it'll be, what times what is 4 tan squared? Well, that's 4 tan times 1 tan, right? 4 times 1 is 4, tan times tan is tan squared. 1 times 1 is 3, 3 and 1, you do the correct sign to get the middle. Make sure you guess and check correctly. Same thing here. We guess and check. Over here we get 2a and a, 3 and 2, plus minus. Alright, same thing here. Instead of a, it's going to be 2 cosine of alpha, and then cosine of alpha. Because 2 cos alpha times cos alpha is 2 cos a alpha squared. 2 cos a times negative 2 is negative 4 cos a. Positive 3 times cos a is positive 3 cos a. Negative 4 plus 3 is negative 1 cos a. And then positive times negative 2 is negative 6. You can also do the SOAP formula. Sum or difference of cubes. So hopefully you remember your SOAP stuff. We cube root. Then it'll be the first thing times itself, the 2 times each other, and the second thing times itself, and then you do same, opposite, always positive. So same thing here. Then we have another one. You can't factor the different words, trig functions, so we have to use identities. So we just say, oh, you know, secant squared is the same thing as 1 plus tan squared, so I'm going to replace that. I'm going to combine like terms, which looks like this, and then I'm going to factor. What times what's tan squared? Well, tan a times tan a, and we get the same thing. Alright, we also have this. This is also different squares, so I did that. Then I remembered the fact. So cosecant squared minus cosecant squared is actually 1, so this replaces the 1. I'll leave this other one alone, and that just means it stays this other thing. Then I say, oh yeah, cosecant squared is equal to 1 plus cotangent. So I'm going to replace this first one with 1 plus cotangent. plus cotangent. Combining terms, I get 1 plus 2 cotangent. You also have grouping. So pair them up. We have 4 more terms. The GCF of the first part is cos squared x. That leaves us cos x minus 1. GCF of this is negative 1. Since the parentheses are matching, pull that as a GCF. And then the other one would be cos squared x minus 1. This is a difference of squares. I can square root them. I get cos x, 1, 1, plus minus. Then these do multiply together, or we just say squared. Alright, simplify sine of y plus cotangent of y times cosine y. So we want to see sine and cosine. So I'm going to change cotangent into cosine of y divided by sine of y. Alright, now I can multiply this fraction. Cos y over sine y times cos y. This will be cos squared y over sine y. When you add fractions, you common denominator. So I'm going to make this left side have sine y on the bottom. So I'm multiply sine y over sine y to get me sine squared y over sine y. Once the bottoms are the same, you can combine the tops, leave the denominator the same. Sine squared plus cosine squared is the Pythagorean identity, which is 1. So this is 1 over sine y, which we can say is cosecant y. Alright, here's another one, adding fractions. So first, we gotta do common denominator. So I multiply the first one by sine p over sine p, the second one by 1 plus cosine p over 1 plus cosine p. Once I do that, the bottom's the same. I'm not going to even change it. But sine p times sine squared p, then cos p times this. I'll just leave it like that for now. I'm going to distribute it. Cos p times 1 is cos p times cos p is cos p squared. I'm actually going to rearrange this, put the cos squared first. The reason why I'm doing that is I can now see sine squared plus cosine squared. That should be 1 plus cos p. From here, I know some cos p is on top and bottom. I'm going to just factor 1 till we see it. But then I can cross these out. So all we have left is 1 over sine p. 1 over sine p is the same thing as cosecant of p. Alright. Rewrite without fractions. So remember, if you have something weird on the bottom, you can always multiply the conjugate. When you do that, that turns it to a difference of squares. The nice thing is 1 minus sine squared is equal to cosine squared. Alright, so now it's really one term. I can now split this fraction into two fractions, 1 over cosine squared minus sine squared over cosine squared, and I can split this even further into sine x over cos x times 1 over cos x. So sine times 1 is sine, cos times cos is cos squared. This is going to be secant squared x. This is going to be tangent x. This is going to be secant x. So now it's a new equation, the same thing but without fractions. Alright, that's it for the video. Hopefully you enjoyed it. Make sure you ask any questions. See you soon in class. Bye.